up from our last lesson here, 1 through 8. Number 1, I'm just going to read through them all. Okay, number 1 is x equals 1/2 y plus 1/2. And when your input or your output is -6, your input is -5/2. Number 2, x equals plus minus the square root of -y plus 1. When you input that or output that -6, you get an input of plus minus root 7. And number 3, x equals the cubed root of x minus 2, all plus 1. When your input's or your output's -6, your input would have to be -1. All right. Tell your neighbor how you did on those 3. Talk about questions you might have. Any questions on those 3? Good conversation. Okay, next one, number 4. And number 5, those are our graphs. Now, let me actually focus on number 4. The inverse of it, we talked about in class, g of x equals 1/10 x. So you graph one of your lines, your original, your other would be a reflection over y equals x. So you should be able to just check that by drawing your line of reflection in. You could have graphed this one and then reflected without actually finding the inverse. That would be up to you. The book tells you to solve for x and then switch your x, y values. I usually switch my x and y and then solve for y, but either way works. Okay. Number 5, your graph should look like your inverse function is actually g of x equals -5x minus 35. It's really tough to get that y-intercept of -35. But if you have your points for function f, you can always just switch your values and switch your x and y values and plot those points. That'd be a lot easier than trying to go down to -35 there. And number 6, you would have g of x is equal to 4x minus 5, 6. Once again, it's a reflection over y equals x. Okay. All right. Talk to your neighbors about those problems. Yeah, you did? What's that? Okay, any questions? Yeah, Aaron? That seems to be the common question up here too, yeah. So you've got to multiply by 4/3, right? To get this 5, 6, down here you're going to multiply by 4/3. Hey, all the side talking, it's very difficult for people to pay attention. 4/3 here, which means you're multiplying that by 4/3 and that by 4/3. When I multiply by 4/3, it cancels out and it gives me 1. So when this gets multiplied by 4/3, I end up with 20/24, which reduces to 5, 6. And this is 4/3 y. Okay. Good question. Other questions? Okay. Number 7 is nope, because not all x's and f of x's or x's and y values are transposed. So remember, it's they're inverses if what was x becomes y, and what was y becomes x, which happens on all of these except for the last one. Now, I think in your book, my other class said that this was different. Like, are these values different in your book? 1, -3, 3, 1? That's what you have? Oh, okay. Maybe they're just joking with me. Funny, funny, ha ha. Maybe, hold on, maybe it was on this, my other page. Oh, it is. It's on my other page. Yeah, like on the page I was teaching from the other day. That's odd. Actually, they're both odd. Huh.
It's a Monday.
Come
I'm
on.
sorry.
All right.
It's a Monday.
Okay, number 8, the answer is nope, because not all x's and f of x's are transposed. In fact, only one set are. Okay. All right. Any questions on those two? Okay, let's go ahead and turn your page, please. Let's take a look at the next page, problems 9, 11. I want to work through. Okay. go to y equals. Yep. Yes, when you change to the inverse, I always want it to be in the form of y equals. Okay, so, ladies and gentlemen, we are going to find the inverse of the function. I want you to do that on number 9 first. Off you go. Don't worry about graphing it, just find the inverse. Okay, well, let's see. To find the inverse, first thing is to take the cubed root. Right? Well, let's set it equal to y first, right? Y is equal to x plus 2 cubed. And like I said, I personally like to switch the x's and y's. Now, on a lot of my answer keys, I actually leave it like this and solve for x. But I like to switch x and y first, usually. This textbook, I guess, does it both ways. So this will give you now the inverse when you transpose your x and y values and now solve for y. So we have to take the cubed root of both sides. That gets rid of the parentheses there. I then subtract 2, so I get negative 2 plus the cubed root of x equals y. Okay? Okay. Now we need to graph it. May be helpful to think about what a cubed root looks like, a cubed root function. So, as I was talking earlier, as you get to math analysis, they're wanting you to be able to do more graphing by hand. We should be able to look at this function and think to ourselves, our original function, a cubed root graph. I want you to just right above it sketch what a cubed root looks, or excuse me, a cubic function looks like. What a cubic graph would look like. And so hopefully everyone was able to just do this real quick. That's a cubic. Okay? This plus 2, tell your neighbor what that means about that. Okay, volunteer, what's it tell us? Tell us? Good, it shifts it to the left 2 units. Now, with that being said, I'm going to actually go up by 2's here on both my axes, just so I have enough room. I don't know if I'll need all that, but I'm pretty sure I'm going to go from my origin, and I'm going to shift over 2 units. That is the slided part, the part where our graph slides. Okay, now I'm just going to pick some values on either side. So, like, plug in 1. 1 plus 2 is 3, and 3 cubed is? Let me try that again. Let's plug in negative 1. Negative 1 plus 2 is 1, and 1 cubed is 1. Okay, so we're going to put in 1, 1, which would be right there. Now let's plug in 0. Negative 1, 1, sorry. Let's plug in 0. You get 8. 2, 4, 6, 8. What do we appreciate? Math? Math? Yay. Okay. And this point is just down here as well, and this one's going to be down at negative 8. Okay, so my function does this. Yeah, woo is right. That's amazing fun. Okay. Now I should actually try to be more precise in my graphing and actually have it cross the line x equals negative 4 at that point. Okay. There's my function. Now it's inverse. You can go through the same process that we just went through, or you can just reflect these points. This that was negative 2, 0 is now 0, negative 2. This point that was negative 1, 1 is now 1, negative 1. And this point that is 0, 8 is now 8, 0. This point that is, let's see, 3, or negative 3, negative 1 is negative 1, negative 3, which means I have to go and put it at negative 1, not positive 1. Ridiculous. Good thing I'm using an amazing pencil. And this last point, that is negative 4, negative 8, is negative 8, negative 4. Negative 4, negative 8. We're going to have negative 8. What am I doing here? Negative 8, negative 4. My goodness. Try that. I'm having a hard time with all these points. All right. Yes. Monday. All right. Cool. And when you check it, you should go, hey, man, that looks like a reflection. That looks pretty cool. Now you have something else to draw in your binder and stuff. Student journal. You little. All right. Why don't you guys try number 10? Okay. Hey, there is the inverse I have. The fourth root of 3x plus minus fourth root of 3x. Don't forget the plus minus. Okay. Please note that they give you a restriction here. X has to be greater than or equal to 0. Tell your neighbor why that is the case. Okay, does anyone know why that is the case? It's not it. Walsh? Well, we're only dealing with this function right now. So they're giving you the restriction for that one. Sylvia? He could. When you're looking at, when you make this a negative, look at the function changes from, let's just say x is negative 5. Oh, I think I know what you mean. Yeah, so let's say x is negative 5. Okay, so we could go through and actually do that, right? 4 or negative 5 to the fourth, we could come up with a value for that. Okay, it's just when we plug in a negative value and we keep going through here, is that what you're saying? It's not going to work. I think that might be what Walsh is saying as well. That you're negative over here, you won't be able to take the negative value of that. Is that what you're saying? Okay, yeah. Okay, so the negative values will work into this one. However, they're not going to work when you've got the inverse of it. Okay, so what you're going to end up with here, I take this, I've got 0, 0. It's a fourth root, right? So it's kind of like a, what does it look like? What's a fourth power function look like? It's kind of like a U, maybe flattened out. It could be if you have other values of x, like x to the third, x squared, and so on. You could get a little bump in the middle or something like that. Okay, but this one's just a flat graph. And when I have 0, 0, when I plug in 0, I get 0 out. When I plug in 1, what do I get out? I get out 1/3. When I plug in 2, what do I get out? 2 to the fourth is what? 16 divided by 3 is about 5. Okay, so just over 5. Okay? And we're not going to get any other points in there that are going to fit onto this grid at least. So we've got 2, and that's probably plenty. Just don't cross this line. Okay? So that is our function f. If I want to reflect that and make the function g, that'd probably be the easiest route. So I'm still at 0, 0 because that happens to be on the line of reflection. This point here is going to move to right there. This point here is going to move to about right there. They are aesthetically pleasing. Good call. G. Yeah. Actually, we're not calling this one G yet, so let's call it G, just so that we're accurate. G of x equals plus minus 4th root 3x. Gee whiz. Cool. Any questions? Yes. X has to be greater than or equal to 0. You still need x to be greater than or equal to 0. Yeah. Okay. Hey, any questions? Yeah, let's check the next one. Actually, you like the next two. Why don't you tell your neighbor? Use the graph to determine whether the inverses of f are a function. Explain. Here, I'll even give you a hint. I'll let you... Are you guys ready? You get 30 seconds to look at this other page. It's a note page. 30 seconds is about up. However, lucky you, it's on page 150 of your student journal too. Use the horizontal line test. Okay, 11. Does it pass a horizontal line test? No. Now, you guys, let's make it clear why it would have to pass the horizontal line test. When you do an inverse, you're thinking, remember, you guys know the vertical line test, right? Okay. When you're trying to figure out the inverse, it's reflecting over the line y equals x, so we're doing a horizontal line test. Now, this graph would cross in multiple places on a horizontal line test, so this is no. The inverse is not. However, this one works here. Works here. Does it work here? No, this one is not either. Super ridiculous. Okay? In order for it to be a function, it'd have to pass the horizontal line test. And if you want to experiment with that a bit more and you're like, I don't quite get it, then reflect this graph over the line y equals x. It'll make a lot more sense to you on why it has to pass the horizontal line test. Okay? By the way, are both of these functions? Are their inverses functions? Yeah. Passes the horizontal line test, pass the horizontal line test, and their inverses pass the vertical line test, which is the rule when we're figuring out if a function is, or if an equation is a function. All right. Determine number 13. We're going to do one more together, and that's it. Okay? Which one do you want to do, 13 or 14? Okay, how many want to do 13? How many want to do 14? Okay, let's do 14. Okay. Hey, we want to see if they're inverses of each other. Tell your neighbor how you're going to do that, or what you think you should do. Okay, can someone tell me what we're trying to do, just so we're all on the same page? No one? Zach? It's true, we are. So how are we going to do that? Solve the first one. Okay, take the parent one, and what are we doing with it? Swap the x and y values. Could you do that in this one? Yeah, it doesn't matter which one you use. Just swap your x and y values and then solve for y in one of your functions. If you do it in the second one, then when you swap the x and y's and solve for y's, it should end up being that. Okay? If you do it in the first one, if you swap x and y and solve for y, you should get that if they're inverses. Okay? So you want to know if they're inverse. So since I have more room, I'm going to do it in the second function just because I have more room over here. Don't want to be confusing. So let me call this, let's call this y. Switch x and y now. I only put those parentheses just so I kind of keep track that I actually did something there. I transpose those. Okay? And then from there, if I want to get y by itself, let's get rid of that too. And if I have a fifth power, a 1/5 power, how do I get rid of the 1/5 power? I have to raise it to the fifth power, okay? The reciprocal power. Okay, so by doing that, I get x minus 2 to the fifth power is equal to 6 minus y. Now what do? Move the 6 over, so x minus 2 to the fifth minus 6 is equal to negative y. Yep, divide out a negative 1. So what that does is it makes that positive. It makes that positive, and it makes this negative. Are they the same? Yes. Yes, they are. Are they inverses? Yes, amundo. Okay? Your work would work as an explanation there. All right. Okay, while I'm handing out your assignment, why don't you guys try 13, and I'll put the answer up here in a minute. Okay? The previous problem there. All right. Are they inverses? No, they are not. Okay, notice this time when I showed my work on this one here, I waited till the end to transpose my x and y. All right, so I actually solve for x, and then at the very end I switch x and y. That's what the book does a lot. So the answer is no. This is not the same as that. They look very similar, but this is minus 1/5, and that's minus 1. That would be bad. Okay, so nope, they are not inverses. All right, you got your assignment? Off you go. Need help, make sure you're asking.